Hello everyone, my name is Yang Bo. I'm now working in Japan. I'm from the Multimodal Communication Laboratory of KDDI Research Company. In this video, I'm going to give you a presentation on the subject of facial expression recognition with the advent of face masks. And here is the outline. Firstly, I would like to give a brief introduction of the background for facial expression recognition, and we name it as FER for short. Then I will explain the existing automatic wearing face mask method and our proposed method, and we also name it as AWFM for short. Following this is how to construct the simulated masked FER dataset using AWFM method for training models, along with how to collect the real masked FER dataset for evaluation or for test. Finally, will be the evaluation of experiments results and conclusion, which also includes future works. Well, before introducing facial expression recognition, it is very important to define the facial expression classification in the first place. In this figure, it shows 7 basic expressions, which is defined by CAC cooperation, which is also used in their famous FER products with the name of FDEX. Still, there are also some other classification ways, like 6 basic expressions. And even for 7 basic expressions, in some studies, there is natural instead of the device. Facial expression recognition is very important in social robotics, medical treatment, driver fatigue surveillance, and so on. In some papers, the vocabulary of expression and emotion is misused. In fact, expression is the outer side emotion on face, while emotion is the inner side deep in one person's mind. And we should note that expression is culture-specific and not universal. Like Asian people is apparently different from Europeans in several expressions. In this figure, it shows the existing technologies in how to train a FER model. The traditional one consists of 3 steps. Step 1. Image pre-processing. Step 2. Feature extraction. Step 3. Machine learning classifications, such as SVM. Recently, the most famous one is end-to-end FER systems using deep learning methods such as CNN, LSTM, and so on. The FER is started for a long while, and many products are already sold on the market. However, as the COVID-19 pandemic has now spread all over the world, almost everyone has to wear a facial mask in public. Previous study also shows that the facial part around the mouth can be highly informative in distinguish expressions, like between sadness and disgust, or between fear and surprise. So, when the facial parts on the nose bridge is covered by facial mask, it will be definitely decrease the performance of existing FER systems. However, there is still good news. Some psychology studies has shown that many people tend to rely on the eyes to figure out an expression rather than the mouth or the nose. To study FER with masks, the first problem is that how to collect enough data for FER with mask. The simplest way is to paste the mask on the existing FER dataset with an automatic wearing face mask method. We found that the basic ones consist of 3 steps. Step 1. Divide the mask into left side and right side. Step 2. Resize the left half and right half of the mask according to the person's left face and right face. Step 3. Combine the resized left half and right half of the mask again into one, and then paste it to the person's face. We tried to find some existing codings from a website, make them run, and process our FER dataset. For both AWFM21 and AWFM22, it is apparent that the results are not so perfect, especially when the face is turned to one side. To solve this problem, we proposed a new method to automatically wear face masks. For the case of side view face, we use side view mask instead of front view mask. The mask can be in any color and any shape. Then according to face shape, height and weight, we resize the mask LH and LW and use the top point of mask to paste it on nose bridge point, which is a landmark feature that can be detected using existing technologies. For the case of side view face with rotation, the face is not only turned to one side, but also rotated by a certain angle. Step 1. We also resize the mask according to face, like what we did. Step 2. We calculate the offset of mask according to the angle, and paste it to the face. Take the finger for example. We use the formulas on the right side on the bottom. To train our FER model, we process existing FER dataset using the proposed method. The FER dataset is a very famous one named LFW, which means labeled faces in the wild. This time, we are not using the 6 or 7 basic expressions dataset. For step 1, we label the LFW dataset with 3 labels: neutral, negative, and positive, to obtain a dataset LFW FER. For step 2, process the LFW FER with the AWFM method to obtain a dataset M LFW FER. LFW FER and MLFW FER datasets are also released to GitHub in the URL on the bottom, which is also for public study. Then we also tried to collect the real masked FER dataset in negative, neutral, and positive for fair evaluation. Then we crowd real masked facial expression fingers from the internet, like from Google, using keywords such as smile face with mask or angry face with mask. Our experiment is conducted using simulated masked FER dataset for training and a real masked FER dataset for evaluation. And we use LFW FER, which is based on public dataset LFW. MLFW FER is to process LFW FER with the AWFM methods. And KDDI FER is our private dataset with 17,236 samples from 5 females and 7 males. MKDDI FER is based on KDDI FER and also is processed with our proposed AWFM method. Then we use MKDDI FER for test or evaluation. The collection method is the same as we introduced. And finally, 562 masked FER fingers are crawled from the internet. Now, let's look at the evaluation results. For process methods, unmasked denotes the original FER dataset without masks. and the front wheel mask only denotes the existing AWMF method 1. Front wheel mask only face cut denotes the existing AWMF method 2. And the front/side wheel masks face cut is our proposed method. We also conducted the experiment using two deep learning models. The names are MobileNet and VJJ19. From the result values, LFWFER and KDDI-FER show a relatively lower detection accuracy on MFERT, which demonstrates that the masked face will decrease the performance of models trained on unmasked FER. The proposed method shows better accuracy compared with the existing method where only front wheel mask is used, in terms of training, validation, and testing on both MLFWFER and KDDI-FER. So finally, let's draw a conclusion. In this paper, we evaluated the accuracy of masked FER on MobileNet and VJJ19. And then we proposed a new AWFM method which improved the masked FER accuracy. And finally, we released the first masked FER dataset to public in the following GitHub URL, which can be used as a validation or test dataset for other researchers. In this work, there is still a problem needs to be solved. The level of recognition accuracy on test dataset is still insufficient. So we are considering to solve this problem in the following three ways. First, enlarge the training dataset. Second, design a new model which can focus on area around the eyes. The third one is to generate various shaped facial masks, use GAN method, and so on. Finally, thank you very much for listening and watching.